Hello and welcome back to California Geology. I'm Dr. Robert Lopez, and I want to continue on with this earthquake forecasting, or at least probabilities. And again, this file that I'm showing here on the screen, the uniform California earthquake rupture forecast number 3 that came out in March of 2015. Again, I'll make it available for you to read on our Angel site, but I want to highlight a couple of things. One thing that this report has on here, which I thought was kind of interesting, is this figure here, this figure 3. And what it shows, it shows this, they call it an earthquake readiness of faults. And it's really the elastic rebound theory by Reed, how he developed basically that faults are strained, so they accumulate strain, and eventually rupture occurs, and then they release that strain. So in this case, here where we're looking at this elastic rebound theory right in here. And so the faults that have had earthquakes recently are the ones in blue, like the 1906 San Francisco earthquake, the Coalinga earthquake of 1983. There was one in Kern County, and there were a couple of earthquakes in the 90s that were magnitude 7s down in the Mojave Desert region over here. And so those are not have a low readiness. In other words, have a lower probability of having another large magnitude earthquake on them. But the ones that are particularly ready, or the ones that have been accumulating strain for quite some time that haven't had a rupture within the recurrence interval, are the ones in red here. So you can see the Hayward Fault, particularly the northern segment of the Hayward Fault, up Berkeley and up in towards Rogers Creek area. And then the Calaveras Fault as well has not had a large magnitude earthquake. We had the one in 2007, which was magnitude 5.4, but that may actually cause some accumulation of strain on the Calaveras for a larger event. And then as we go farther down the San Andreas, you can see that the probability gets a little bit higher here in the Fort Tejon area, although we did have the big earthquake in 1857 there. But then, but it's been 150 years, or almost 150 years since that earthquake. So we're looking at a higher probability here. And then you can see it's really red down here in the southern San Andreas. And I think there was an earthquake back here in 1680. So this one hasn't ruptured in over 350 years. So it's well overdue for a large magnitude earthquake. Now, if we go back to our PowerPoint and we'll compare the 1906 San Francisco earthquake with the Loma Prieta earthquake of 1989. And so this 1906 earthquake was a pretty enormous event. It ruptured for over 477 kilometers. It's over 200 miles. And the magnitude was about 7.8. And all the way from Shelter Cove up here, where the San Andreas Fault leaves land, down here to San Juan Bautista. In comparison, the Loma Prieta earthquake only ruptured about 40 kilometers, right, and about 28 miles. And so this earthquake magnitude 6.9. So you can see just basically one order of magnitude here difference, and how much bigger the 30 times bigger, 30 times more energy is being released during this event, the 06 event, compared to the 1989 event. Then this is a map showing the intensity of shaking after the 1989 October 17th earthquake here, 5:04 p.m. You can see that the main shock was in the Santa Cruz Mountains along the San Andreas Fault. And the reds here, you can see that there's violent and heavy shaking, heavy damage, and then we had some 9s over here. And then you can see as you go farther away toward the Bay Area, where you get into San Jose, where there's kind of softer sediment, you're seeing more of these 9s, even though you should see a decrease in intensity. And then you see some pretty high intensities here along the bay where the cypress structure fell here. And obviously over here in the Marina District where there was damage quite a bit as well there. Then when we go over here to this intensity map, this is actually a reconstructed intensity map based on interviews and accounts of people that had written down what they had felt. In the 1906 earthquake, geologists have reconstructed a shake map for this event. And you can see all the reds. Remember, all the reds are intensities 9s and 10s. And so the main shock was probably we think was right off the Golden Gate here. Remember, there was about 4.7 meters of offset here at Point Reyes Peninsula. But you can see all the Santa Rosa had quite a bit of damage, and all through the Stanford had quite a bit of damage, all through the San Andreas Fault. You can see there was pretty high intensities along the coastal regions here, from basically Shelter Cove up here all the way down to San Juan Bautista. Now, this is a scenario, right? So if a magnitude 6.7 quake were to occur on the Hayward Fault, right? What would be the possible shaking intensities? And you can see that the intensity is quite high to the west of the Hayward Fault, because down here, well, we have a dense population. More people are living in this region here, as opposed to the Berkeley Hills up here. And also there's some softer sediment. The rock is softer here, especially in Alameda area over here. So you can see there's going to be some really high intensities in that region there. And then you see that it dissipates as you go farther away. One last thing to review with a seismic gap. I pointed out this on the earlier talk, how Loma Prieta was predicted to be an earthquake, and we had expected some event to occur there, and sure enough, it came in 1989. Then we also talked a little bit about the Paso Robles gap back over here, and also in 2004 there was an earthquake that occurred here in Parkfield that has filled in this gap. And then we got the South San Francisco gap that has not been filled yet. And this other map here shows basically earthquakes in the San Francisco Bay Area, and up to about maybe 2004. So some of them, not all of them, are on here. But what I want you to know here, that we do see the Santa Cruz Mountains being filled in quite nicely. And then once you go over here to South San Francisco, you see there's a big gap here. I mean, there's some in this region here, but here's the seismic gap in the South San Francisco region, Los Altos Hills, Portola Valley area right in there. Okay, we'll stop here for now.